What's the difference between multicore Proc and multiproc system? I wonder what's the difference between a dual-core computer and a computer with two processors on the motherboard. I think it's something related with the threads, but I don't understand it very well.
You should start with multi-core and multi-thread articles at Wikipedia. A softer starter, the difference between multi-threaded and multi-core programming. More hardware-oriented, demystifying multi-threading and multi-core.
From a software development perspective, there is relatively little difference. Some incorrectly written multi-threaded applications may accidentally work on a multi-core processor, but not on a multi-processor motherboard. But I would not lose too much sleep over that, since, well, we're talking incorrectly written software. The main difference between the two scenarios for the same total number of available cores, for example, 1x4 core processor versus 2x2 core processor, is that in the case of the multi-processor scenario, there is typically a larger aggregate memory bandwidth. This means that for any workload that is memory-intensive, you may be better off with the latter. Note, however, that locking primitives may actually be a bit slower, depending on hardware implementation, so algorithms that use a lot of synchronization may actually perform worse on the latter. Even so, I would not worry too much about the difference even then, because if you work in an area where this difference matters, then you'd most likely already know about it, domain-specific knowledge.
Well, it's about scaling horizontally instead of vertically. In the old days, they used to make CPUs faster and faster. Over time, the speed of CPUs increased from only a handful of megahertz to super speeds ranging up to 3 gigahertz. However, when the 3 GHz speed was reached, CPU makers had found a limit to how far they could push the speed on a single CPU core. While this speed race was happening, for those applications that needed more power, like servers and CGI render farms, the multi-socket CPU motherboards were introduced. This allowed to be more than one CPU, usually two, to be placed on the motherboard. Operating systems that were able to utilize multiple CPUs at once could run software that took advantage of this feature by distributing load over those two CPUs, therefore increasing execution speed. Fast forward to present day. The CPU speed limit is somewhat reached, and instead of scaling vertically, making it faster, CPU manufacturers are starting to scale horizontally by placing multiple cores on a single chip. Currently, dual-core chips are very common, and soon the quad cores will be the standard. Now imagine that you'd place 2 quad cores on a single motherboard. This would mean that the operating system would have access to 8 CPUs, all running at around 3 GHz. Besides multi-core CPUs, there is also a fake dual-core CPU that uses a technology known as hyperthreading. With hyperthreading, the CPU emulates the presence of 2 CPUs when there is in reality only one actual core present. The CPU knows how to make use of what would normally be downtime by scheduling instructions in a specific way, gaining more efficiency.
Multiple processors let your computer do literally 2 things at once, instead of only seemingly doing 2 things at once, but actually just swapping between tasks extremely rapidly. Multiple cores are the same. The advantage of multiple cores over multiple processors is that they share some bits of the CPU, e.g. the second-level cache, which makes it possible for them to work even more efficiently if they have some shared data. This makes them much cheaper to manufacture. A single dual-core CPU also takes up less room than 2 single-core CPUs, which is an important factor these days with everyone moving to laptops. There may be some performance differences, but nothing you're likely to notice.